Alright. So we can have it the symbol notation. So we have something here. This is the symbol, element symbol. We also have the hyphen notation. In which we have element and some number here. This is the mass number. Mass number is number of protons plus number of neutrons. And this is the atomic number, which is the number of protons. So you can find the mass number by adding the atomic number, which is number of protons, to the number of neutrons. It is also the number used in the hyphen notation, and the top left number of the symbol notation. The atomic number is the number that identifies what type of atom. It is equal to the number of protons. It is the bottom left number of the symbol notation. If you are given the element symbol, or name, you can look the atomic number up on the periodic table. So for example, carbon, looking it up on the periodic table, this is the name, this is the atomic number, which is equal to number of protons. This is the symbol, and this is the average atomic mass. Yes, it is. Sorry, I was got off track. Should be 12.0107. Because mass number is equal to number of protons plus number of neutrons. So number of protons is atomic number. So doing a little bit of math, we can solve for atomic number. Atomic number is also equal to mass number minus the number of neutrons. So in summary, everyone good? I'll let y'all catch up. Wait until y'all get into really hardcore college, where literally not only are you constantly writing, you have to write extremely quick, as the professor does not stop and pause and let everyone catch up. So in summary, if you want to find the mass number, if you were given the hyphen notation, that is the mass number. If you were given it in symbol notation, the top left number is the mass number. If you were given the protons and the neutrons, the mass number is the sum of protons and neutrons. I would also say that if you were given the number of neutrons and the atomic number plus number of neutrons is mass number. So there are lots and lots of different ways you can calculate the value based on other information. The major definition is mass number is number of protons plus number of neutrons. To figure out the atomic number, if you were given the name, you can just look it up on the periodic table. If you're given the number of protons is the atomic number. If you're given the mass number and the number of neutrons, then you can do a little bit of algebra. Atomic number is equal to the mass number minus the number of neutrons. So let's look at the number of neutrons. So again, mass number is equal to number of protons plus number of neutrons. Number of protons plus number of neutrons. So if you want to solve for the number of neutrons, we just subtract the number of protons from both sides. So the number of neutrons is just equal to the mass number minus the number of protons. And another name for the number of protons is the atomic number. So the number of neutrons is equal to the mass number minus the atomic number. If you're given it in symbol notation, A, X, Z. So this, again, is the mass number. This is the atomic number. Thus, the number of neutrons is just A minus Z. So number of neutrons, A minus Z. So you just subtract these. Put a minus sign on line, subtract them. If you were given the hyphen notation, so we have the element with the mass number. Look up atomic number on periodic table. And then you just do number of electrons. Not electrons. Neutrons would be equal to the mass number minus the atomic number you found on the periodic table. So, for example, carbon 14. So looking up on the periodic table, so this is the mass number. So mass number is 14. This number for carbon is the atomic number. So the atomic number is 6. So the number of protons is 6. And the number of neutrons will be the mass number minus atomic number, which will give you 8. And if charge is not indicated, assume neutral. Unless it says ion. Ion means has a charge. No, we will most definitely know what ion means later in the year. You will be able to look at an atom, and if it's an ion, you will know exactly how many electrons it has. We will learn that later. For now, though, we're just mostly keeping up with the structure of the atom as we're going to build off and figure out how the electrons are configured in the atom, what orbitals and energy levels they are in. Then we'll eventually figure out valence electrons. Valence electrons tells you everything about how it's going to work. It'll make sense later, but this first unit is almost entirely just the structure of the atom and a little history of it. A neutral atom has same number of protons as electrons. The charge of an atom is equal to protons minus electrons. Charge equals protons. I will admit, I do not think I have ever used this. How I remember charge is if you have 2 additional electrons, you have a charge of -2. If you're missing 2 electrons, you have a charge of +2. Right? That's how I think of it, is how many additional electrons do you have, or how many electrons are missing. The reason why we won't use this is we'll learn later on that an entire group is missing 3 electrons, and you really don't care about protons. You just know they're all missing 3, so that means they all have a charge of +3. You'll notice that all the ones in this other group is going to have an additional electron. Again, we don't care about how many electrons and protons it has total. If you add a -1 charge to something, it gets a -1 charge. It was neutral to begin with. So I actually put that in words. If you add X number of electrons to a neutral atom, its charge will be -X. For example, if oxygen gains 2 electrons, its charge is -2. If you remove X number of electrons from a neutral atom, its charge becomes +2 or +X plus X. For example, if calcium loses 2 electrons, its charge becomes +2. Make sense? Oh, before I forget, I made a mistake. I keep meaning to correct it every year. I don't know why I got this in my mindset. That this was the correct answer. I just keep assuming it every year because it makes sense to me, and I realize it's wrong. Because none of the PowerPoints mentions it. So, do y'all remember how I said James Chadwick discovered the neutron? I said it was because he discovered that atoms have different mass. That is not correct. The discovery of the neutron. We go down. So some people were working with alpha particles, and they noticed that these particles produced radiation that penetrated quite deep into this material. So they asked themselves, they knew that this radiation had to have been neutral, because if it had a charge, it would have been deflected by the material they're hitting. They assumed it was gamma radiation, but what James Chadwick did was he fired alpha particles. Y'all remember what alpha particles are? So an alpha particle is a particle with +2 charge that contains 2 protons and 2 neutrons. Is the nucleus of a helium atom. It is the nucleus of a helium atom. Again, we knew about alpha particles before we knew about the atom and stuff like that. We knew about charges. We knew electricity. We know that there was a flow. Electricity was the flow of charges. We know that if we ran electricity down 2 wires, they would have a negative charge, and if we put them next to each other, the 2 negative charges would repel each other. Actually, I take that back. We didn't know that it was negative. We actually assumed it was positive. But it doesn't make a difference. It's sign convention. Positive and positive repel. It doesn't make a difference if it was negative or positive. We just knew that it was charges. We later flipped notation and assigned negative to electron and positive to protons. But an alpha particle is just a helium atom that's been stripped of its electrons. Or we thought it was its own particle. It didn't act like normal atoms because, again, it was just a nucleus. It's actually easy to make. It's one of the most common types of radiation from radioactive stuff. We have beta particles, which are just electrons. We'll learn that here directly. And we have mostly 3 types of radiation. Alpha particles are neutrons, beta particles. Beta particles are just electrons, and gamma radiation. But anyway, he sends these alpha particles and hits some paraffin wax. So he's aiming it at like a candle. And he realizes that whenever these alpha particles were to hit this wax, they traveled about the same distance as protons. So he basically did it with wax and without wax. With wax, the protons would stop. But these new particles would go through. These neutrons would go through, and they would eventually stop at some distance. He then removed it and then shot protons through, and they also stopped at some distance. What he basically figured out was that there had to have been a neutral particle that had the same mass as a proton. If it was gamma radiation, which a lot of people thought it was, gamma radiation is just like light. It wouldn't stop. It would be able to continue going for a long distance. So basically, he discovered neutrons by shooting alpha particles at some wax, and discovering that there exists a neutral particle with the same masses. So, James Chadwick discovered neutrons. by shooting alpha particles. At paraffin wax. He actually, let me just replace that. He discovered neutrons by shooting alpha particles and detecting a neutral particle that had the same mass as a proton. He did repeat the original experiment used paraffin wax, and he did repeat it in paraffin wax to prove it. But he did multiple experiments. So he performed a series of experiments showing that the gamma ray hypothesis was untenable. They discovered. So he repeated the creation of radiation using beryllium to absorb alpha particles. So you take a beryllium-9 isotope, an alpha particle, helium-4, and it created carbon-12 with this new particle. N1 is neutron. And then he repeated the Paris experiment, showing that he aimed it at paraffin wax, which has a lot of carbon in it, so it's dense in protons, and it scattered some of the protons. So when the neutrons hit some of the atoms, and when the alpha particles hit some of the atoms, some of the protons were scattered off. And he measured that the protons in this new particles had the same mass as the proton. They went the same distance. If that makes any sense. Any questions? Y'all think y'all got mass number, atomic number down? I want there was something I don't like about it. think it was just has like alpha particles. So tomorrow we'll be going over nuclear chemistry, in which case we'll be writing nuclear equations. Yes. Which shouldn't take you for like a few minutes to do. I will say this also. Do you know one of the important things that the neutron did? There's a little history. I guess I'll go over it tomorrow